good morning students. I am here once again with a new topic, namely electric flux. Here the word flux, what is written, is a Latin word which means to flow. Before reaching the electric flux, I would like to start with the fluid dynamics and the explanation of flux in that section. If we are considering flow of a fluid with velocity v through a small flat cross section ds, where v is normal or perpendicular to the cross section, then the volume flow rate is given by volume flow rate is equal to volume flow per unit time. Here volume can be determined by the length covered by the flow of liquid in a given time. Here L I had taken multiplied by the cross sectional area, what we had is ds divided by t. L by t, the distance covered per unit time, is denoted by v into ds. This is the expression for volume flow rate when the velocity is normal or perpendicular to the small cross sectional area. This is the expression which is known as flux across a given cross section for a fluid. But the second case arises when the velocity flow is not perpendicular to the area taken over there. Or you can say this velocity or direction of velocity is making an angle theta with a perpendicular over the given planar area ds. Then in that case, the volume flow in a time will be the area of cross section multiplied by the length or the height of the equivalent body. So in this case, volume flow rate is given by, once again, volume flow per unit time. Here the volume is v dash. I am not taking exactly at that of v. You see here the area of cross section remains same. The equivalent horizontal length in this case is L cos theta. So that can be written as v, this is L cos theta into ds divided by t. L by t is called velocity and this is the magnitude of velocity v into ds into cos theta. This can also be written as here v dot n ds. Here n, this is the theta which the velocity makes with this vector normal to the surface. You can determine the same expression by taking in other way the mathematical expression. Suppose if we are taking the component of area or the projection of area which is perpendicular to the velocity vector, and that is nothing but flux is equal to the magnitude of velocity into the component area, this is our projection area, that is ds cos theta. This is v cos theta into ds and this can be written as v dot n ds. Here this would be theta. So by taking projection area we can find out the flux as well, which is given in NCERT, or you can follow this method. Here the rate you just follow down. In this, this volume can be compared from there what you have studied in dot product in class 11th. That can also be taken care of while finding out this, and that can be clear to all of you. Now related with this, we are going to find out one quantity namely in the electric field called electric flux, which is the analogy of this, in which there is no such flow of physically observable quantity, unlike in case of fluid or liquid flow. Now the strength of electric field, which is defined as number of electric field lines per unit area placed normal to the field at a point, is the measure of strength of electric field at that point. Here we have taken very small area. This is electric field line normal. So this is electric field strength, delta S. The number of field lines crossing normally to a small planar area, delta S, is proportional to E into delta S. Here we are not taking quality sign. The reason is, it depends on how many lines we are choosing to draw from a given charge. So it is physically significant to say the relative number of field lines crossing a given area through different points or at different points. What we have seen, when this area delta S is normal to the electric field vector, that is, it is same as that one line drawn. It is the line what is shown there, the same thing. So in that case, number of field lines crossing small area delta S normally is proportional to E delta S, what we had just seen. But when we tilt this area, what happens? Just see. If this area, the whole number of lines were exposed, now when we tilt this area, the number of lines reduces. It means in that case the orientation also, or the exposed area, is only delta S cos theta. So this here, instead of E of delta S, we are going to write E into delta S cos theta. So not only the magnitude of strength of electric field and the area, surface area, elemental area, we have to take care of the orientation of the area as well. So with the orientation or direction, the value of exposed area is also changing, or field passing through that area is also changing. So here area will be treated like having certain direction. What we have studied in class 11th, that the cross product of two vectors, that the area is normal. Suppose this is the area, magnitude of this is delta S, then the area vector is this, and this is nothing but, you can write delta S, area vector is magnitude of delta S into unit vector. So this is the area vector when it is plane. But what happens when it is curved? Now the direction of area, what we had been talking about. When plane surface is taken, what we have just discussed, as per the cross product two vectors, the area vector is normal to the plane of the given element. So delta S normal is this, so that is what we have taken. This is the area direction. So delta S is equal to S into L, what we have seen just now. For curved surface, here curved surface is divided into a number of different small sections or areas, and small area is considered. Then what will be direction? Here also, is it one side or other side? So a convention is drawn, and that convention taken is outward normal will be taken as the direction of area. So the magnitude, this remains same, and when the whole area is considered, we have to integrate this. So this is the direction of area considered over there. Now we know the direction of delta S, that is the area vector. It is normal to the plane of the element of area, and for closed surface it is outward normal, which is the convention what we had chosen. We are here to definition of electric flux. Electric flux delta phi through an area of element delta S is what we had already determined. This delta phi was this much. That is the number of lines. It is proportional number of lines cutting an area element through that delta S. where theta is the angle between E and N or E and delta S. Here delta S is shown, so if it is E is in this direction, then theta is this, or E and N or E and delta S. In the same way here as well. So theta is the angle between E and N or E and delta S. It can also be explained delta phi E, other way to explanation, E into delta S cos a scalar multiplies, all the three are scalars, so you can multiply in either way without any order. So delta S cos theta is nothing but projection of area normal to E. Projection of area normal to E means the component which is of this, which is perpendicular to this one, the electric field. So E times delta S cos theta, delta S is this, and delta S cos theta is this much. In the same way you can find out, or E cos theta into delta S, that you have learnt in lower class in vectors. We have taught it. So E cos theta into delta S, and that is E per E cos theta is the component along, or you can say suppose E was there, so the component of E along this, that is nothing but E cos theta into delta S. That can also be written component of E along the normal with the area element delta S. That is what it is done. So finally it was for small area delta S. Total flux through closed surface, this is algebraic sum of all the flux through all the small segments of this closed surface, and this small segment should be almost negligibly small or very small, and this whole section is taken as integral, that is closed integral, and that is surface integral of an electric, so E dot ds. Now the flux, what the formula we have derived this one for closed surface. If the surface is not there, directly we are taking any value, it's not closed, then or electric field is always also constant, then you can directly use E dot S. So that is the formula for us. Now the discussion point, positive flux. What is the meaning of positive flux? Phi positive, so it's quite obvious, E ds cos theta positive. E is magnitude, ds magnitude, always positive. So cos theta has to be positive. Cos theta positive means in between, in the first and fourth quadrant, acute angle, open interval. So first and fourth quadrant means less than 90, and here also magnitude on both the sides should be less than 90. So this is the open interval I am showing. So field lines are coming out. Less than 90 means field lines should be making less than 90 degree with vertical or normal or area vector, you can say. So this is field lines are coming out of surface. Now the negative flux. Negative flux means phi negative. So E ds cannot be negative, so only cos theta will be negative. So theta will be from pi by 3, pi by 2. So that is second and third quadrant, 90 to 270. That you know in these two quadrants only the flux is, so that cos theta will be negative. So in this case field lines are entering, drawn. Here the figure, it is with vertical or area vector, it is 90 to 270. So this is here field lines are going inside the surface. Third is zero flux. Phi 0 means only three options, either E 0 or ds 0 or cos theta 0. If these two are not there, so it will always be 0, but if cos theta is 0, then we have two values, 90 or 270. So 90 means here, there, and 270 means up to this. In this case, only two values are there, fixed values. So it is tangential to, field lines are tangential to the surface. Now the unit, you know the E dot ds is the flux. So what is the formula for E? Force by charge, you have read it. So force is Newton, charge is Coulomb, so Newton per Coulomb is the unit of electric field. Area, meter square, so Newton meter square per Coulomb. One more formula you are going to learn, E equal to minus degree of dr. So this is volt per meter, and area is meter square, so this gives volt meter. And the dimension formula you can directly find out by using the formula for flux. These two questions has come in exam, and it has come number of times, not one time, but this has come once or twice, but it is not less than 10 times what I saw in board's exam. So these are also important to all of you. Now the questions of electric flux. Here the small questions are coming in theoretical section, like the definition of electric flux, units of electric flux, nature like scalar or vector of electric flux. But it is coming almost after alternate year. In alternate year is coming, so you can see some attached numericals are there. So we are going to see some numericals, that is NCERT 1.5, the first part from A to B, and NCERT 1.16 attached with this, so I have written it together. So first part, the NCERT, consider a uniform electric field. So electric field is given to you. That electric field is 3 into 10 to the power 3 I cap Newton per coulomb. Part A of the question. What is the flux? You will find out. Of this field through a square of 10 centimeter on a side whose plane is parallel to the YZ plane. So now we have first the axis. This is x-axis, y-axis, z-axis. Here YZ plane either parallel or on the YZ plane. I am going to put it here, one of the plane. Its side is 10 centimeter as per the question. Now what we see, the electric field along x-axis, electric field is here, E, the data value is given there. Area is perpendicular plane. This is also along x-axis. Y perpendicular to YZ plane is along x-axis. So you can write this as A vector is equal to A into I cap. What is A? A you are going to find out 10 length into breadth, 10 centimeter into 10 centimeter, 100 centimeter square. So that is in meter, 10 to 100 into 10 to power minus 2 minus 4 meter square. So that is equal to 10 to the power minus 2 meter square. So area is 10 to the power minus 2 I cap. Electric is given. So phi, you know that constant, what I had just explained to you, E dot A, E is given 3 into 10 to the power 3 I cap. Dot product is area vector to the power minus 2 I cap. So this is 10 to the power minus 2 I cap. Take the dot product these two. So 3 this and this simply give you 30, and I dot I, that is going to give you 1. So this is 30, and we had put the SI unit here converted meter square and here Newton per coulomb. So this is Newton meter square per coulomb. That is the answer of the first part of the question. So we have field along x-axis of 3 into 10 to the power 3 I cap Newton per coulomb. For same electric field, what is the flux through the same square if normal to its plane makes a 60-degree angle with x-axis? So normal to plane means area vector, that is making an angle 60-degree area vector. An electric vector, electric field, you know that is along x-axis. So here you know area is 10 centimeter by 10 centimeter, that is 100 centimeter square. So that is 100 centimeter square, and that is equal to 100 into 10 to the power minus 4 meter square. So this is 10 to the power minus 2 meter square. You know the flux phi is equal to E dot A, area vector. This is E into A into cos of the angle between E and A, electric field and area vector. So a magnitude of E, 3 into 10 to the power 3. Magnitude of A, 10 to the power minus 2 SI unit. So 10 to the 3 into 10 to the power 3 Newton per coulomb you can put here, and A is 10 to the power minus 2 meter square and cos 60 degree. So this is going to give you 3 into 10 30 Newton meter square per coulomb. Cos 60 is half, so that is equal to 15 Newton meter square per coulomb. Now the second part of part B, plane is making 60 degree with a field. So that is what E is this, A is this, remains same. So 60 degree with a field means we are having axis like this, X, Y, Z, electric field the same what we have, and 60 degree with a field means suppose this plane was in YZ plane. So now 60 degree with the field is somewhat like this, and here also. So this is the plane. So this plane turned by 30 degree. So the area vector is somewhat like this. So it is making 30 degree, turns by 30 degree. So this is the area vector and this is the electric field vector. So this angle is 30 degree. So once again, phi is E dot A, so that is equal to E into A into cos of the angle between E and A. That is, E is the magnitude 3 into 10 to the power 3 Newton per coulomb. A is 10 to the power minus 2 meter square, and cos 30 degree we have. Either take clockwise or anti-clockwise, minus theta is cos theta is no problem at all. So finally this gives you 330, cos 30 is root 3 by 2. So that is Newton meter square per coulomb. So this is 15 root 3 Newton meter square per coulomb. That is the answer of the second part. Part C. What is the net flux through a cube of side 20 centimeter? So area is side 20 centimeter into 20 centimeter. So 400 centimeter square. So 400 into 10 to the power minus 4 meter square. So 4 into 10 to the power minus 2 meter square. So this is what we have. Area. For the same electric field we have, as this question is from NCERT, which is attached with the previous question. It is given in NCERT, you can see there. So electric field once again along x-axis, that is equal to 3 into 10 to the power 3 I cap, the SI unit. So no problem at all in that. This is for 3. Now this area, actually what is the net flux through a cube of side 20 centimeter? So cube of side 20 centimeter, so here this is the cube I am going to make, and so all sides are 20 centimeter. Flux is, this is left side, this is right side, this one is up, this is down, and front and back. So flux through all the sections we are going to see. Electric field on this is rightward. Here also rightward. The area vector on right plane rightward, on left plane outward normal. Area vector for up, area vector for down. So one by one we are going to see here. So area we have finally 4 into 10 to the power minus 2 meter square. Now for one by one we are going to search. First is phi on left side of the plane, this plane. So phi on left side is once again E dot A. Electric field you have 3 into 10 to the power 3 I cap. Dot, we say on left side, so area remains same, 4 into 10 to the power minus 2. And left side means minus I cap. So 4 into 10 to the power minus 2 or minus I cap. That is SI unit. So this is minus 4 to your 12 into 10, so 120 Newton meter square per coulomb. In the same way, phi right is E dot A. For phi right, so this is the right plane, rightward, so it is area and electric field in the same direction. Here area was on leftward, it is rightward, so one it. So that is what, either you write in magnitude or in direction, no problem at all. It is up to you. Here 0 degree, or you can use vector method or the simply substitution by taking angle. So this is E dot A, E is rightward, A is also rightward. So 3 into 10 to the power 3 I cap, and this is dot product rightward. So A is 4 into 10 to the power minus 2 I cap. So this is once again plus 120 Newton meter square per coulomb. For rest of the phases, for this up, electric field rightward, area upward, so 90 degree. For bottom face, electric field rightward, area downward, once again 90 or minus 90 doesn't matter. For front, field is rightward, it is towards you. For back side, field is rightward, area vector is away from you. So in all the cases, phi is 90 degrees. So here, so angle between E and A is 90 degree. Here 90, here 90, front 90, front area electric field rightward, area vector towards you. Back side, electric field rightward, area vector away from you. So in 4 out of faces, like up plane, topmost, bottom plane, 5 bottom, 5 front, 5 back. So 5 front, 5 back. For all the cases, this is 0. Because this phi is E dot A cos 90 degree, and that is E into A into cos 90 degree, and cos 90 is 0, so reality is 0. So net flux of this cube is 120 plus minus 120 plus and 0. So finally it is 0. If you sum all this minus 120, this plus 120, and for rest of 4 0, so net is 0. Total flux is 0.